Well, hello everybody, here we are, we're back, and today we're going to work on this big old coffee can capacitor and get that installed. And you'll see on the schematic it's right here, and it has a 4.7K bleed resistor that goes on top of it. And if you recall, it's a lot bigger than the one that was there. So I've got it in the hole. I don't have it clamped in yet, it still floats freely. And what I've done is I've stripped back the wires and I put some of these loop connectors on them, on both sides. And we're going to get this installed, but I have to be a little concerned because I don't want this to short out, right? It is a wood case here, but I don't want anything to short out, so I have to invent something to make sure I don't have that problem. So here's what I've done so far. I've got a 4.7K resistor and I've soldered it to these feet. Okay, and the plan is to put this there, put the screws through the loops. That's not good enough. So what we're going to do here is I'm going to use this as an insulator. I'm going to put the screws in. I'm going to put the resistor in so that it comes out this hole. Remember, it's a 2-watt resistor and does need to dissipate heat, so I have to allow the heat to escape. So I'm going to connect all that in, and then I'm simply just going to fold this down when all the connections are made, and that should keep things nice and insulated. Okay? So that's the plan. I'm going to go ahead and do that, and I will be right back and show you how it looks. Okay, so I have everything connected like I said. I put the insulator on the bottom. There's my resistor, and there's my 2 connections. We're going to go ahead and tighten that down. And keep in mind here, there's the positive side, so I have that going to the positive side. So let's go ahead and tighten this down. A little hard to do with one hand. We've got to make sure we have a good connection on these, obviously. Okay, nice and tight. And then the plan is fold this over. There's my bleed resistor. And I'll just apply a piece of tape here or something to hold this back. But that's how the poor man creates an insulated connection. So that's that. I'm going to flip it over, tighten the bracket that holds the can in, make sure I have the right clearance. But that's now in circuit. And again, I've got these lugs soldered to the original wires that were here. So we're going to go ahead and tighten that up. Be right back. Okay, so in order to tighten the clamp, I have to remove this heat sink to give myself some room. So let's go ahead and tighten this clamp down. I think I'm going to need 2 hands here. I think that bolt is spinning on the back side. Let's see. Maybe not. Okay. So now we have our can. It's nice and tight. Okay. And you'll see that I do have some clearance here. The can is not protruding out above the front, and it's not protruding at the back. Okay, but I do have this insulator in place to protect it. Okay, so we can declare that one a success. Now we just have to put this heat sink back on, and we'll move on to the next part. So I'll be right back. Okay, so now we're going to tackle this this 4,000 microfarad cap. And you'll see I've got my 2 wires, my positive and negative, coming out of here. And this is a spring-loaded clamp. I've taken the screws out of the bottom, and this just kind of pops out here like this. Okay? And we're going to take this out. Don't have a lot of wire there. Questions. Do I snip it? I think we're just going to snip it. Then I can solder on terminal leads, just like I did with the other one. As you recall, the new cap has screw tops as well. So we're just going to go ahead and snip this thing right close. There's your red. There's your black. Get that sucker out of there. There you go. And this is a 4,000 microfarad 50 volt DC. Okay? And I am replacing it with a 4000 microfarad 100 volt DC. We should test that cap though and see what it looks like. Let's throw it on the old LCR meter here and see what we get, just for fun. Okay, here's positive side. Okay, so we have the negative side connected. Let's power this thing up, see what we get. That's resistance. That's inductance. So we're getting 4.5 millifarads. So we're getting about 4,500 microfarads here. So it's a little high, it's a little out of tolerance, which is okay, but we're going to replace it anyway. Let's move the connectors over to the new one and see what we read there. Okay. And you'll see we're at 3.86 millifarads, so within spec. I think we're good. Alright, so let's go ahead and get this thing connected in. I'm going to go back here to these wires. I'm going to strip them. I'm going to put connectors on the end that fit into these screw tops, and then we'll get this thing mounted, so we'll be right back. Okay, we have our connectors on there. They're cooling off. They're all soldered on. I crimped them and then soldered them. And next plan is going to be to mount this cap right there, like that. Connect everything up. Put this bracket on it. Put the screws on the bottom of the chassis. And we're good to go. Okay, so that's the next plan. I'm going to let these cool off for a minute because they're really hot. And we'll be back shortly. Okay, so we've got that cap mounted in there, and the clip that was on the old one is too small because this cap is rounder. So as the saying goes, when all else fails, use tie wraps. That's what we did here. It's in there tight, but I'm not exactly happy with the stability of it. So I'm going to do a couple of things to help strengthen it. I'm going to put a little dot of hot glue right here. Okay, I'm going to let that set up. I'm also going to put a dab of hot glue down here where it meets the chassis. Okay, let me go do that because I need two hands. I'll be right back. Okay, so we've got the hot glue here, and we have a little dab of hot glue down right there, and this thing is rock solid now. It's not going anywhere. So mission accomplished. Alright, so recap, no joke intended. This is done. This is done. My next experience here is going to be to figure out what to do with this one. If you recall, the cap I have is much larger. Unfortunately, on this amp, this is all dead space here. There's nothing that goes in there. It's pretty big space. So what I think I'm going to do is I'm going to drill some holes here. I'm going to mount the cap to the back chassis. This cap right here. I'm going to mount it, and I'm going to run the leads down to the circuit board. That's the plan. Let me go think about that one, and I'll come back and show you what I decide. Alright, I'm going to wait on this one. I'm not exactly sure that's what I want to do. I've marked some holes here where I would go through. I have to rethink that. So I'm not going to work on this now. What I'm going to do next is I'm going to unsolder these transistors, show you how that works, and we'll get those replaced. Be right back. Alright, so this is the Hakko FR300 desolderer gun. Works really, really well. Has a nice strong vacuum in it. There you go. Interesting little things, but they work really, really well. Got to keep the tips clean. And there's also a temperature dial on the bottom. Okay, and right here is where the mark is. So I have it at about 2.5. These Heathkit boards, not exactly made well, so you can't overheat them or the pads will just come right up. Okay, so you'll see here. We're going to work on this transistor first. Someone globbed a lot of solder in here, so we're going to take our time and try to get this cleaned up. So let's see what we can do. Alright, this has proven to be a little tougher than I thought, so I'm going to put the camera down, get this done, and come right back. Well, it put up a fight, but it's out. You know, one thing about these old Heathkits, mostly they were built by people that weren't professionals, obviously. And you'll see here that this is a huge mess. But you can see daylight through the holes where the new transistor goes. I'm going to go ahead and clean those pads up. I'm going to use some alcohol, get them nice and clean, and I'm going to mount the new one in and we'll solder it in. So I shall be right back. Okay, so we have the new transistor pack placed in. It's not soldered yet. And as you can see, this thing is a pretty big chassis, so how do you turn it upside down and solder it without that falling out? So here's a little trick. Take a piece of painter's tape, put it over the component, make sure that it's firmly in the socket, like that. There you go. And then when you flip it over to solder it, it's going to stay in place. So let's do that. Alright, we've got that soldered in. We're going to clean it up just with alcohol. Make sure we get the flux out of there. And then all we have to do is go ahead and snip those leads that are hanging up, and we're pretty much done. So I'm going to wrap this one up for now. I'm going to go ahead and replace the rest of these transistors, the other two, and we'll pick back up in the next episode. Thanks. One other thing, because this connection is so dirty, I want to just test continuity and make sure I don't have continuity between the pins. So let's go ahead and do these two. Nothing. And the center one, nothing. And here, nothing. Okay. I do have continuity on the center pin here, which is where it connects. Okay, so I know that I've got a clean connection there. All right.